Welcome to section 9.4. In this section we're going to graph linear inequalities in two variables and solve systems of linear inequalities. So first off, you need to know what is a linear inequality that has two variables, not one like before where we just had x, but these are inequalities that have two variables such as x and y. Okay, a linear inequality in two variables, it looks like this. It's any inequality that has basically two variables and all numbers. And they can always be written in this form where capital A, B, and C are numbers, and that should say capital A and B are not both 0. Okay, so a solution is any ordered pair x comma y that makes the inequality true. So let's look at an example. The linear inequation y equals x minus 1 is shown to the right. So that's a linear inequation. Okay, a linear inequality is really any linear equation that instead of an equal sign, it has an inequality there. That's all it is. Okay, so what an inequality would be is that all the points on one side of this line y equals x minus 1, are going to satisfy y is greater than x minus 1. So what I'm doing is I'm changing the equal sign to a greater than sign, and all the points on the other side of the line will satisfy the inequality y is less than x minus 1. So I'm changing this inequality to a less than sign. So all points in the plane, any point that's at least not on the line, will satisfy one of these two inequalities. So how do you figure out which side is which? Well, let's plug in a point and see. So let's plug in this point 1, 3 right there. We're going to test the coordinate point 1, 3. Let's try plugging it into this greater than right here. We're going to plug it into y is greater than x minus 1 and see if we get a true or false inequality. Now this means x is 1 and y is 3, so if we plug that in, we'll have 3 is greater than 1 minus 1. 1 minus 1 is 0. Well, is that true? 3 is greater than 0? Yes, that's true. So I got lucky and picked the right side. So apparently what that tells us is that any point on this side, because 1, 3 is on this side of the line, will solve this inequality. Y is greater than x minus 1. So it looks like this is the top half of the plane. The xy coordinate plane is what I mean. And then if we did it correctly, what that means is that any point beneath the line or on the other side of the line satisfies this half, the bottom half of the plane. Okay, let's do a check here. Let's plug in a point on the bottom half of the plane to this other inequality and see if it's correct. So let's test the point, how about this one, 2, negative 2. 2, negative 2. I'm going to plug that into this less than inequality that says y is less than x minus 1. It should be true. Y is negative 2. X is 2. Is negative 2 less than 1? Sure, that is true. Okay, so that means that point does solve this inequality. And let's do another point so we can show you when it's false, what it looks like. So if, for example, I was to plug in 2, negative 2 up here, if I tested 2, negative 2 into this inequality, y is greater than x minus 1, we should get a false inequality. So let's see. We'd have negative 2 is greater than 2 minus 1, which would give us negative 2 is greater than 1. That's not true at all. So we get a false inequality if we try to plug in this point into the inequality that describes the upper half of the plane. Okay, so what's interesting about a linear inequality is that any point on half of the plane will solve the inequality. So for example, all the solutions to this inequality are all of these points. You really just have to shade it in. Any point on this side of the line solves this inequality. Now because there's no way to list out all these infinitely many solutions, what we do is just typically graph all the solutions by shading it in like that. And now of course you have to imagine that this plane extends on forever. So there's actually more points out here. They go on forever. Okay, so we graph the inequality solution set rather than list them out because there are infinitely many solutions. So how do you graph an inequality? Here's some steps for you. First, you graph the boundary line. That would be, for example, the line y equals x minus 1 in this case. Okay, to do that, you're going to have to change this inequality sign, such as in this example down here, to an equal to sign. And then we graph that. Now, if you have an inequality that says strictly greater than or strictly less than, then that means any point on the line will not satisfy the inequality. So in this example, because this is strictly greater than and it is not a greater than or equal to, that tells us that if the point is on the line, this inequality will be false. Therefore, we don't include points on the line, so when we graph it, we actually graph it as a dashed line instead of as a solid line to indicate that points on that line are not a part of the solution. Okay, then you choose a point not on the line as a test point. So up here, for example, that would be any of these, marked points, really any point in the plane that's not on the line. You plug that point into the inequality, the original inequality, and then step 3, if you get a true statement, that means that the half of the plane that you pick the point in, your test point in, is the true half of the plane described by the inequality. If you get a false statement, then it's the other half. So let's do that for this example right here. Okay, first we need to replace this inequality by an equal to sign so that we can figure out how to graph this line. So this is the line x minus y equals 3. That's going to be the boundary line that cuts the plane in half. Solving for y, I'm going to add y to over here and subtract 3 to over here. So we'll have x minus 3 equals positive y, or y equals x minus 3. So that has a y-intercept of negative 3 and a slope of 1. And remember, we're graphing it as a dashed line because really any point on the line is not a part of the solution. So it would look about like this. So there's the line y equals x minus 3. Okay, now this is an inequality, so we know that that means one half of this plane contains points that make this inequality true, and the other half has points that make the inequality false. We just have to figure out which half is which. So what you do is you pick any point not on the line. And I like to pick easy points. So I'm going to pick 0, 0 is my test point. Now if I plug that into this original inequality, not the equality where we changed the sign, but the original problem, I would get 0 minus 0 is greater than 3. Well, 0 is definitely not greater than 3. That's false. So that means any point on the other half of the plane, so any point down here, should make it true. So we're going to shade in this half of the plane. Okay, your shading should look a little bit more neater than mine since I'm trying to do this digitally. Okay, any point down here will make the inequality true. Let's check one more time just to test and make sure we're correct. Let's see, how about the point, if I pick 5, 5, that will be, I know you can't hardly see what I'm doing, but here's the point, say 5, negative 5, 5, negative 5. That should make it true because that's in the red half of the plane. So let's test 5, negative 5. Plugging that in for up to here, x is 5, so we'd have 5 minus negative 5. Is that greater than 3? Yes, 10 is greater than 3. That's true. So we did that correctly. And any point on this half of the plane solves this inequality. Now a point on the line should make it false. So let's test a point on the line. How about that one right there? 3, 0. Let's test 3, 0. Plugging in 3 for x and 0 for y, we'll have 3 minus 0 is greater than 3. 3 is not greater than 3. 3 is equal to 3, so that's a false equation. Okay, so that's why we have a dashed line so that we don't include those points on the line. Okay, make sure you're trying these, of course, and pausing the video before we do them together. On the next one, we'll do the same process. So we'll change the inequality to an equality so that it becomes x minus 4y equals 4. And solving for y, let's see, I'm going to add 4y to both sides, subtract the 4 from both sides to give me x minus 4 equals positive 4y. Divide everything by 4, and I'll reverse it as well, so we have y equals x minus 4 all over 4. Now that's not a standard form, so I'm going to keep going and write it in slope-intercept form. This would be y equals x over 4 minus 4 over 4 if we split it into two fractions. In slope-intercept form, that would look like 1/4, that's a 1/4, x minus 1. So this means it has a y-intercept of -1 and a slope of 1/4. Now this inequality has an equal to sign. It says where is x minus 4y less than or equal to 4. So we can graph a solid line because any point on the line will also be a part of the solution set. Okay, so from here I'm going to graph a solid line, and I'm going to do it using slope. Slope is positive 1/4, so we go up 1, right 4. Just go up 1, right 1, 2, 3, 4. There's the next point. Up 1, right 1, 2, 3, 4. It would be about right there. Or we can go down 1, left 4. Okay, and drawing in that line looks about like this. Always label your lines. So this is the line y equals 1/4 x minus 1. Okay, now we have to figure out which half of the plane solves this inequality. So again, I can pick 0, 0 because that's not on the line. So let's test 0, 0. Plugging that in, I have 0 minus 4 times 0 is less than or equal to 4. I want to see if is this true or false. Well, 4 times 0 is 0, so this is 0 minus 0, which is 0. Is 0 less than or equal to 4? Yes, that's true. So that means any point on this whole half of the plane or on the line solves the inequality. I recommend shading lightly, especially because if you mess up, you're going to have to erase. And actually, if you mess up on one of these, I would actually just start over on a new graph rather than try to erase. But shade lightly because of what we're going to do next, coming up down here. So let's do another example. Where is y less than 3x? Okay, so we changed the inequality to an equality to get y equals 3x. And this does not have an equal to sign, so we're going to graph a dashed line. Y equals 3x goes through the origin, has a slope of 3, so we go up 3, right 1, up 3, right 1, or down 3, left 1, down 3, left 1. Oops, and we're graphing a dashed line. This is why you use an eraser. So dashed line. Okay, and we'll need to pick a test point. Can't pick 0, 0 because that's on the line. So how about 1, 1? That one's easy. And always make sure you're showing your work over here. I know you can probably do a lot of this in your head, but by showing your work, you're showing me what you're thinking. Okay, that way I know that way I can read what you're thinking and what it is that you're doing. Just because you can do something in your head doesn't mean you should do it in your head. Okay, so plugging in 1, 1, we have 1 is less than 3 times 1. 1 is less than 3, that's true. So that means anything on this half of the plane must solve the equation. Okay, and with this example, I'm going to point out something that you might have noticed or might not have. It's another way to read off which side of the plane is going to make your inequality true. Okay, now notice this one is solved for y, so it's easy to look at on this one. It says, where is y less than 3x? Okay, now if you view this as from sort of going from top to bottom, that means where are your y values less than the line? Okay, in other words, because this is a less than, that means below the line. Any y value below the line will make the inequality true. Now I know this really kind of looks like it's the right side of the line, but if you think in terms of vertically, okay, think of a vertical line moving across, really any point less than the line is making this inequality true. Okay, so that's another way to look at it is if it's solved for y, it's easy to do it this way, to say, well, that's the same as saying where's y less than the line. Or what you could do down here on this one is first solve for y and then read it off that way so you'll know which half of the plane is to be shaded. So that's actually how I prefer to do it over doing test points. And I recommend doing test points until you get good at it. But I'm going to show you this other method for this example. So we could solve this one for y first. So we'd have 2y is greater than or equal to negative 3x plus 12. Dividing both sides by 2, we'd have y is greater than or equal to negative 3x plus 12 all over 2. Let's make it look more like your standard line. So that would be negative 3 halves x plus 12 over 2 is 6. Okay, so that tells me this says y is greater than the line y equals negative 3 halves x plus 6. So anything above the line will be the half that is shaded. But first I have to graph the line. So first we're going to graph the line y equals negative 3 halves x plus 6. Because there's an equal sign there, I can graph a solid line. 6 is our intercept. Oops. So 1, 2, 3, 4, 5, 6. The slope is negative 3 halves, so down 3, right 2. Down 3, right 2 to get to the next point. Okay, and I can graph a solid line. Now if I solved my inequality correctly, it should be, because this says greater than, that should mean any point above the line. So you have to think vertically here to figure out which side is above, but you can tell this is the upper half, right? So it should be that any point on that half solves the inequality. Now let's check with a test point. I'm actually going to test with the checkpoint 0, 0, and I should get a false inequality. If I test with 0, 0. Now it's best if you go back to the original inequality. That way, in case you messed up, you will realize that you had an error. So let's plug it into the original inequality, in which case we'd have 3 times 0 plus 2 times 0 is greater than or equal to 12. This is 0. 0 is not greater than or equal to 12. That's false, which is what I expected to get. I expected to get a false answer because I know 0, 0 is not in the solution set up here. So that's how you solve, or graph, rather, show all the solutions to a linear inequality. So a linear inequality has infinitely many solutions, and it's half of your xy plane. Okay, this one's slightly different, so I do want to look at this. Graph the inequality x is less than 2. Now this one has no y's, as you can see. There's no y's to solve for, but we can still figure it out using the same process. We'll change the less than sign to an equal to sign. So first we have to graph the line y equals 2, of course as a dashed line because this is a strictly less than sign. Well, x equals 2, I hope you remember, that's the vertical line right here that goes vertically through the point x equals 2. Now this says graph the set where x is less than 2. So let's choose a test point. How about 0, 0? It's easy. Now when I plug in 0, 0 into this inequality, I plug in 0 for x, and there is nowhere to plug in y, so it doesn't matter. Is 0 less than 2? Yes, that's true. So that means this is the half of the plane that solves the inequality. Okay, let's move on to solving systems of linear inequalities. Now this is fun. A system of linear inequalities is 2 linear inequalities. Okay? A solution to a system of inequalities is an ordered pair that satisfies both of the inequalities. So for example, here's a system of inequalities. There's 2 linear inequalities here. Okay? The solution set is the set of xy points that actually makes both inequalities true. So the process is the same. First we're going to solve one inequality, then we're going to solve the other inequality, and we'll say, okay, the solution set is where those 2 inequalities overlap. Okay, so we'll do that by graphing as well. So let's start with this one, and I'm going to get you into some good habits at this point in the class. If you have 2 equations or system of stuff, later on we'll do things with 3 equations, and especially when you work with 3, you've really got to label your equations so that you don't get lost with which is which equation. So I'm going to call this one 1 and that one 2. And I always circle my numbers, that way I don't get confused and think it's an actual number. And I'm just labeling. This is equation 1, this is equation 2. So I'm going to come over here with equation 1, which is the y minus x is greater than or equal to 4. And first we'll solve this inequality. Okay, solving for y, we'll have y is greater than or equal to x plus 4. I solved that one for y because this one's really easy to do. Now we have a greater than or equal to sign, so I can graph a solid line for the line y equals x plus 4. Y equals x plus 4 goes through 4 right here, has a slope of 1. And there it is, y equals x plus 4. Now the half that solves this inequality will be, it says y is greater than x plus 4, so any y's that are above the line, because it says greater than. And if you weren't sure, you just pick a test value and plug it in and figure it out. But it'll be this half up here. Now what you do when you're shading is because we're going to have to shade two graphs, you shade very, very lightly. Okay, so I'm just going to use a light color, or what you can do is you use colored pencils and use just a light color. So that means anything up here, and I actually recommend doing it like this. Just draw little lines, or shade all in one direction. That makes it easier. You'll see why in a minute. So that all your shadings are kind of in the same direction there. Okay, so anything on that half solves inequality 1. That's the blue inequality. Okay, now let's solve the second inequality. The second inequality says x plus 3y is less than or equal to negative 2. Let's solve that for y. So we'll have 3y is less than or equal to negative 2 minus x, or negative x minus 2. Dividing both sides by 3, we'll have y is less than or equal to negative 2/3 minus x over 3. And I want to write that in your standard slope-intercept form. So negative 1/3 x minus 2/3. Well, that's messy. Maybe we should graph that one a different way, because I don't want to graph points whose intercepts are fractions. So instead, actually, let's just forget I did that. Let's graph this one by plotting its intercepts. That might be an easier way to do it. Plot its intercepts. So remember, the x-intercept occurs where y equals 0. So if I plug in y equals 0, I'll have x plus 3 times 0 is, I'm going to change this because I'm graphing the line to an equal to sign, negative 2. So 3 times 0 is 0, that goes away. We get x equals negative 2. So that's the intercept for that line, is negative 2 is right there. Okay, the y-intercept is where x equals 0, so that would be where 0 plus 3y is equal to negative 2, because I'm graphing a line. Solving for y, we get y equals negative 2/3. Actually, I should have already known that from finding the y-intercept up here. Negative 2/3 is about right there. Alright, all you need is 2 points to graph a line, so if you have what you should do is get out a ruler, okay, and go straight across. Let's see, and this one will be, oh good, it's also a solid line because we have an equal to there. So my graph is going to be a little off because I'm having to do this, digitally. But try to draw a straight line through these 2 points here. Okay, that's the equation x plus 3y equals negative 2. So all I did was change that to an equal to label it here. It should say 3. X plus 3y equals negative 2. Now we have to figure out which half of the plane makes this inequality true. So let's plug in a test point. How about this one, 0, 0? Testing 0, 0, I would get 0 plus 3 times 0. Is that less than or equal to negative 2? 0 is not less than negative 2, 0 is greater than 2. So this is not the half of the plane that solves the inequality. It must be the lower half. So it must be this half down here. Okay, and that's why I do shading in one direction. So now you can draw your lines in the other direction and say, okay, these lines, the orange, are what solves this inequality, the second inequality. Now the set of points that solves both inequalities is the set we're looking for. Now there's no way to describe the solution using x's and y's really, except for just how it's written up here. So we picture it. Okay, the real solution is, because these are both solid lines, any point on either line or any point that's in this region over here where both inequalities overlap. So this is the real solution set. Any point in here will actually solve both linear inequalities. So that's why I said shade lightly, because these two are not really part of the solution set. This darker blue area is the solution set. Any point in there will make both inequalities true. Okay, and let's do another example. Make sure you're trying this on your own first. Okay, first let's label the equations. This one will be equation 1, this will be equation 2. So bringing equation 1 over here, I have 2x is less than y. Because that reads to me backwards, let's just reverse it. That's the same as saying y is greater than 2x. That makes more sense to me. Y is greater than, meaning above, the line 2x. Okay, that's a simple equation from here just to graph line y equals 2x. Goes through the origin, has slope 2. And we have to graph a dashed line. So we go up 2 over 1, up 2 over 1 for the slope. And then we graph a dashed line through all these points. So there's the line y equals 2x. And let's figure out which half makes that true. So this says y is greater than 2x, meaning y is above 2x, meaning above the line. So any point up here, let's do this lighter. Let's do it in a light blue color. Any point up here will make the inequality true. So that's half of it right there. Now let's solve the second equation, or equality, which says 5x plus y is greater than 5. That looks easy to solve for y. Y is greater than negative 5x plus 5. So it has an intercept of 5. And a slope of negative 5. So we'll go down 5, right 1, down 5, right 1. It's also a dashed line. Pretty steep dashed line here. So there's y equals negative 5x plus 5. Now this says y is greater than that line, meaning y is above that line. So if you think vertically here, okay, the above would be this side over here. So above the line is anything in this region. So as you can see, where they overlap is in here in the middle. Okay, I'm not going to re-sketch over it because it will just make it messier, but it's clear that anything in this sort of V, upper V, up here, any of these points, not on either line because they're both strictly greater than less than signs, any point in there will solve both systems. So that is the solution to that system of equations. And let's do one more to make sure you've got it down. So we label the equations first. Okay, so let's let's do the second one first because that one looks quite easy. Y is less than or equal to 3. So first we graph y equals 3. That's the horizontal line. Y equals 3, and it gets a solid line. And where's y less than 3? Y is less than 3 if it's beneath that. Okay, on this one, I'm going to attempt to not actually shade both regions. I'm going to attempt to only shade the solution set region, which is the best way to do it if you can. So by just knowing, okay, anything beneath this line makes this inequality true. Now let's solve the other inequality, which is the negative 2x plus 5y is less than 10. And now if I solve this for y, I'm going to have some fractions involved. So instead I'm going to graph it by plotting its intercepts. So let's find its x-intercept. That occurs by letting y equal 0, so we'll have negative 2x is equal to 10 if that term is 0, which would be x equals negative 5 is its x-intercept. And its y-intercept occurs where x is 0, so that term would be 0. So we would have 5y equals 10 or y equals 2. Okay, so right there. So, and this is a dashed line because it's got a strictly less than sign. So it looks like it has a slope of 2/5. So we go up 2 over 1, 2, 3, 4, 5 to get to the next point. And here's the line, negative 2x plus 5y equals 10. Now for this one, because I didn't solve it for y, I'm going to have to do a test point to figure out which half solves the inequality. So I'm going to test 0, 0 as usual. If I plug in 0 here, that term becomes 0. If I plug in 0 here, that term becomes 0 for y. So we'll have 0 is less than 10. That is a true equation. So this point is on the half of the plane solving this inequality of this line. So both of them I'm graphing beneath the line. So the points that solve both inequalities are beneath both lines. So that would be this set of points here. It's beneath both lines. And then where they intersect, we start to graph only beneath that solid line there. So any point in that region will actually solve both. So it's best if you can do this and not actually shade your graph so that the whole thing looks terribly messy. If you can just grade the part that is the solution set, that makes it the easiest to read. So there you have it. That is systems of linear equalities, and that's it for chapter 9.